If you guys have any updates or anything to put on the agenda, you can go to the agenda here and add. You should have access to make suggestions, and we'll just click those and add them. So, and thank you, Stephen. All right, so I'll start with the usual highlights. There's actually a lot of work going on the Python side these days. Sorry, Paco commented the other day that he's doing more reviewing than development in Python. So it's really great to see some of that progress. So the main things to highlight, 0.4.0 is out with a whole bunch of new features. I also saw that Paco just wrote up a blog post on that, so check out the blog post. 0.4 has things like parsing for SQL expressions, support for delete files so that you can read V2 tables produced by Spark merge operations. Remind me, there's a whole bunch more stuff. Anyway, really good things coming out, as well as great development to see in the community. So a couple other things to highlight. We added or updated Python concurrency so that it's compatible with AWS Lambda and other serverless environments. So that's super cool, and we're excited to see what people are building in serverless. Rusty has been working on basic performance improvements. So one that uses slots and made everything, I think, 18% faster reading Avro files. You know, some really really handy fixes. I think there's also another one out there to cache some of the getters. Just basic Python performance improvements, and it's really great to have the community you know, coming forward with those and making sure that we're you know, doing all the performance things that we can in Python. So thank you. We also recently added an Avro write path to Python in expectation that we're going to be able to start producing metadata files and commit things to tables. So that's a really, you know, critical piece of commits. And I think that's it on the Python side that I noticed, but really great to see all of that progress, especially from new members of the community. And by the way, like, great to see all you new members of the community here. So thanks a lot. Sorry, I can't see comments, so I'm going to move this so I can see comments. All right. Next up, I want to highlight a couple other things on the Java side. So first of all, Rakesh fixed the Spark deleteWhere problem with WAP branches. So this was just when you had a WAP branch set, we weren't respecting the deleteWhere in Spark, which caught out at least one of our customers. So really glad to see that go in. We also added registerTable to the REST catalog. So thanks to Vikash for taking that on. I know that went through a couple rounds of reviews, and so thanks for sticking with it. And then lastly, Stephen added here the Flink flip27 source switched over to a more standard JSON parser. So that was really good to see. We're moving all of the JSON parsers into, I think, core. So thanks for doing all of that, everyone. Next up, wanted to briefly talk about releases. 0.4 is out, so of course, you know, start thinking about what we're going to put into 0.5. I know that we originally said we were targeting write support, but I think that we probably would not want to hold up features in 0.5 just to wait for something. So we may not get full write support into 0.5, but you know, we are definitely working on getting that out and enabling writes from the Python community. Other things going into 0.5, you know, please raise your hand and suggest them, or tell Paco, and we'll put them on the milestone and make sure that we're getting review capacity to get those things out. I imagine that with all the great progress on performance and like write math and Python, we are going to want to have a 0.5 here pretty soon. On the Java side, just wanted to say, please vote on the 1.3.1 release. This is a patch release that Zion put together. And that fixes a couple of serious problems or bugs. And so we'd really like to get that out there. So please take the time to test and vote on the 1.3 release, or 1.3.1. And then lastly, I wanted to talk about Java 1.4. So 1.3 has been out for a little while. 1.4 is coming up next. I wanted to see, is anyone interested in being the release manager for 1.4? And when do we want to target a 1.4 release out? Don't everyone jump at once.
I can do it again as I did 1.3. I still kind of remember most of the process. There are a few notable features that I think I want to have included from the Spark perspective. Locally, I have a prototype for distributed planning to cover those edge cases where you don't have partition predicate, but you have lots of metadata and you're still looking for a small subset of files. I have that locally, so I expect that to be like out tomorrow, for example, and then it shouldn't take too long to get it in. And also, there's a bunch of new features related to row level operations that are in master of Spark, but they are not there yet in our repo because like we did it there first. And we need to cherry pick them here, and that includes like schema for merge and read. It includes support for when not matched by source. Like there's a lot of features that are in master of Spark, but not in Iceberg just yet. But those would be really notable, and them alone would probably make a good like 1.4 candidate from the Java perspective.
Awesome, that sounds good to me. What was the other? Was that a dynamic pruning feature you were talking about at first?
Distributed planning, that was the first one, and then like dynamic pruning is like a stretch goal at this point. Depends on how quickly we can arrive to a solution for it. Mainly we target the merge and read fonts and runtime filtering there, but we'll see.
Okay, well, that sounds reasonable to me. When did we do the 1.3 release? Was that like mid-June? Does anyone know?
I think it was early June or something because we wanted to release 3.4 support and stuff.
So we should probably start really planning in earnest. You know, it's almost August already. So like, if we try and have a release candidate by the end of August, I think that would make sense, right? That way we're on sort of a quarterly basis, which, you know, there's a lot of good stuff going in. So it would make sense to me to try and do one like every 3 months if we can. Okay, so I'm gonna go ahead and say targeting August for release candidate. Cool. Again, anything that you guys want to get into the 1.4 release, you know, bring it up on the mailing list early to try and make sure that we have reviews going towards that, and we have enough time to get things in. Like I mentioned for Python, we don't generally try to hold releases for things that we'd like to get in unless it's dangerous, like there's a you know, correctness problem that we need to fix or an unfinished feature or something like that. But we generally, for new features, would you know, go ahead and release without them and pick it up in the next one because we want to make sure that we're moving fairly quickly. Awesome. So moving on to discussion, I want to, sorry, getting just a ton of notifications. All right, so moving on to discussion, the first one here is the UAPI that we've been working on lately, mostly Edward's work. What we found was that as we're refining the spec and making sure that things make sense, so looking at if we have multiple SQL representations for a view, does it make sense for each one of them to define a potentially different default namespace, for example? So we're moving some things around between the representations and the view versions. One of the issues that we ran into, though, is that as we're doing that, we've already committed some of the interfaces into API. So we have at least an interface problem where we'd like to deprecate an interface or deprecate a method on an interface and move it to the parent interface. Excuse me. And this is made slightly worse by having used immutables and not really thought about where the immutables output was going. So immutables are annotations that we use to generate immutable Java classes behind certain interfaces. We weren't really thinking about that, and it didn't occur to at least me that when we generate those classes, we're generating them in the API package. So we have a lot of generated classes that are showing up in API that probably shouldn't be there. Now that matters more because now we are not just saying, okay, hey, we can default this one method in a single interface. We actually have to deal with the generated code and what happens in 3 of these classes where we've generated implementations and builders for those implementations. And now a single method that we'd like to move is turning into 6 different incompatibilities. So I wanted to at least raise to this group the idea of making a break to API. Now we can, I think, make everything compatible. However, there is no real implementation of views yet, right? The only thing that we've put out there are these view classes for about half of the API. And we don't really expect anyone to be currently using these things. So I wanted to ask, do we think that this is risky enough that it's actually worth, not worth supporting these classes until the 2.0 release? Or do we want to exclude these and assume that no one is using this area?
So this problem is specific to views, right? It's not for all of the generated classes.
Well, so we've generated other classes, specifically action result classes. And our plan there is for those classes to just copy the source for the generated classes into the source tree, and then basically remove the ability to generate classes inside of the API module. So I think there's a larger issue around do we generate classes from interfaces in the API module? And because we don't like having the implementations in the API, I think we should not. But that's really a separate issue. We could make everything compatible here. It's just doing, I think, quite a bit of work for not a ton of benefit because it's very unlikely people are using these generated classes right now.
I mean, from the view perspective, I don't really think that anybody actually uses this. So doing tons of changes just to comply with the policy for something that nobody actually uses, I don't see a reason for that. I mean, it's not really usable at this point. So
yeah. So that was our thinking. Maybe we just allow removing these immutable classes and call it good, rather than doing a lot of work. So it sounds like, unless there are objections, and feel free to bring this up, this is why we wanted to bring it to a larger group. I think we'll just break those classes and do a better job in the future of keeping the generated classes out of the API module. All right.
One follow-up question: how easy is it to evolve those generated classes? So even for, let's say, for the action results, right, the ones that we generated right now, how easy would it be to do changes in the in hierarchy, or just add new methods or something? Is just a purely add in the default, annotation and then it will work fine, or will it be also like a breaking change even if it's in core?
It's the same as like adding a default and then it's mostly fine. So it's kind of the same evolution as you would expect on a pure non-immutable interface.
Okay.
Yeah. Also, like for this stuff, I think we want to have it in core so that like we can move more quickly with at least the like builders and things like that. You know, we want to move slowly on the public API, but internals we want to be able to move more quickly on. Okay, cool. Well, we will not spend the time, you know, bothering with that. Thank you guys for the input. Next up, should projections take in schema versus spec? Zion or Anton, do you guys want to talk about that?
Yeah, I can give a little bit of context. I think this problem surfaced multiple times, and right now what happens is whenever we have a filter that we need to evaluate, we pass it to the projections that basically take a spec and an expression, and then it projects it into an expression that can be evaluated on the partition info. And the problem is that those projections, they bind expression to schema before they do anything. And when they bind it to the schema returned by the spec, which
Oh,
usually is the current schema of the table. So essentially that breaks all of the time travel capabilities whenever you have a filter that reference the column that existed in the snapshot schema, but does not exist in the current table schema anymore. And the problem is like it fails at runtime exception because on the Spark side in the builder, we do the binding to test that the binding will work, but we use the snapshot schema. But once we pass it further, it uses the current schema and then it fails in form. So it seems that we should pass the schema to those projections as well, but that would be a really big change because that's everywhere. You know, so like if there are any better ideas or like if there are objections, let me know.
so I think you're right that in general we should probably be passing the schema that you're using in, because we do need to bind that, I believe. So the spec is valid with the current schema and presumably the old schema.
Yeah, so most likely you can like an alternative was less changes. You could transform the specs and then replace the schema technically before you pass it further. But I'm not sure like it's like a band-aid probably.
I think I mean, what you're talking about sounds reasonable, that when we run a projection, you want to use the spec from the data and the schema that you're actually using for a read. You know, the only issue there is I would want to make sure that we're not, you know, artificially creating a situation where you're going forward or backward in time and like the spec and the schema just are mismatched, right? Because one of the nice things is that we know that the spec is valid with the current schema. So if you don't use that, the current schema, you know, what happens? Is the spec invalid? I kind of assume that it is because we're missing a column. So is this a column that's actually in the spec?
No, I don't think so.
Oh, okay. So this is a column that we're trying to remove from the filter.
Yeah, but I think it can be both as well. But that's a good point about the validity of the spec.
Well, how do we have a filter? Is the filter based on the current schema?
It's based on the schema of the snapshot. So it's like whatever you query, like if you do time travel, you query the schema of the snapshot, not the schema.
Okay. So this is like a deleted column we're going back to when the column was valid and then filtering on that column.
Yeah.
And okay, when we bind the expression, we can't bind it because that column is missing.
Yeah.
Yeah. Okay. I think we may want to introduce introduce a method that allows you to pass the schema as well.
Mm-hmm.
And then we would need to make sure that the schema and the spec are valid together, I think. But yeah, it seems reasonable that we would pass in the runtime schema.
Yeah, I'll double check once again on the validity of this spec.
Yeah.
Trouble. Maybe there would be a simple fix by just discarding. So that use case alone, like when we just need to discard because that's not part of the spec. So it's technically we don't have to bind it, I guess.
Yeah, I wonder if we could do some sort of binding where unknown columns are ignored.
Unless like as long as they're not like not part of the spec or not used by the spec.
Right, right. You could say like, okay, we're gonna ignore those, but then it kind of defeats the purpose, right? Like we've got the projection capability to rewrite that.
Mm-hmm.
So like rewriting and then rewriting again seems a little weird. So
yeah. Okay, cool. I'll take a look.
Yeah. All right. Next up, we have Gradle version catalog support. And I believe this is updating to get rid of the plugin that we currently use for dependency versioning.
Yeah, so I added this item just to raise awareness and like get additional eyes on the PR, and it would greatly help in being compatible with dependabot and removing that older plugin that we use, so that dependabot can for new releases. I mean, we still need to be careful for new dependencies being updated, but at least it could be done later in and all handled by dependabot.
Yeah, that makes sense to me. I do want to call out the one comment I've already made on the PR here, which is that we need to be very careful with these dependency, version, resolution, etc. changes, and make sure that across all of the binaries or artifacts that we produce, we're producing the exact same set of classes. So we have areas where we shade and we build the runtime jars, and we have to, very carefully document in our notice and license files what other projects are pulled into and distributed with those jars. And so it's a big problem if we pull in extra dependencies that we don't know about or something like that. So we do need to make sure, and I've done this in the past, you just like dump the contents of the jar, sort it, and then compare it to the contents of the old jar. It's an unfortunately like annoyingly manual process. But as long as we've done that and verified, like for the version that we switch over to, we're not going to have any like dependence, surprise dependencies in our jars. We should be okay. Oh, awesome. Sounds like you just volunteered.
That was my plan. Like I said, I just wanted to raise awareness and get some additional eyes for reviewing.
Yeah.
On this.
All right, thanks. Next up is applying spotless for Scala code. I doubt there's a lot of objection to this.
I think I might have some because a lot of the code that we have is actually copied from Spark. Sometimes it's copied from the newer versions, and it would be just much easier to maintain it. The formatting would be the same as in Spark. So like, for example, right now, I actually want to migrate and move some of the cosmetic differences that we have in extensions compared to what Spark Master has, because it would be much easier to maintain and cherry pick the changes across the projects. So it's not a hard point, but I don't really see a lot of value given that we don't have much of the Scala code, and that Scala code is most likely temporarily in the project.
So that seems reasonable to me. Do you have an idea of how much code we're going to discard once Spark 3.5 is out? Because it seems like a lot of our code is re-implementing merge and the row level plans, and we're largely going to be able to get rid of that once that's all supported in Spark 3.5.
That's true. So maybe that would be the point to reconsider. But at this point, the row level operation probably take the biggest and most complicated chunk of the code. We do have like custom commands, but those are lightweight and simple. So I'm not sure. We can come back to this once the row level operations are not part of our repo, which I think would be in 3.5. But until now, I would probably just stick to what we have. But that's just my view.
That seems pretty reasonable to me. Xianyang, do you want to talk a little bit about like what the motivation is here and whether that makes sense?
That makes sense to me. I just because we already applied the plugin for Java code, so I would discuss whether we should enable the plugin for Scala code as well, because this could provide a better code management and people clean and a better code style. But the Anton's opinion is also makes sense to me.
Okay, yeah. Well, let's plan on revisiting this when we move over to Spark 3.5. We can see how much Scala code we have and how much that overlaps with what's in Spark. I think that makes a lot of sense just to revisit that once we're hopefully no longer keeping things in sync with the Spark code base.
Okay.
Awesome. Thank you. And last, and I'm really happy to get to this with a good amount of time for discussion, I'll hand it off to Matt to talk about a Golang implementation.
Hi. So for those who don't know me, I'm Matt. Primarily I work on the Apache Arrow project. I'm on the Arrow PMC, and I've been working on a Golang implementation of Iceberg, heavily inspired by the design of PyIceberg, and kind of building off of that, making it more, well, Go idiomatic, I guess. And it made the most sense to me to try to get that into the official repos, since it looks like you guys got, multiple languages already in there. You got Python, you got the Java, so on and so forth. Figured it makes sense for the Go implementation to also live in the same repository. I primarily maintain the Go implementation of Arrow, and so I want to kind of build off of that and make sure there's interoperability, so on and so forth going forward. And then I can also contribute, necessary CI stuff and so on. So I guess that's kind of the background there, and just, I guess, the discussion being, if people are amenable or okay with that, then what do people think is the best way to actually do this? Because I don't think that, huge, gigantic PR is necessarily the best way of doing things.
Thank you. You read my mind on that. I think that we have a couple decision points that we'll probably want to start with immediately, which is, do we want all this in the same repo, or do we want a separate Go repo? We kept Python in the same repo. I'm not sure if we would do that again. I don't really have a opinion here, but I'd love to hear like what is or is not working about that, and Matt, what you would prefer.
One of the nice, interesting aspects of Go, at least, is that releases are primarily just a Git tag. So the only real difference that it makes, whether it's in a separate Go repo or in the main Iceberg repo is the import path for code that people write to use it. For the most part, other than that, then it's just a matter of integrating any necessary things into the existing release scripts, and CI stuff is the only other real differences between doing your own. I know that there was discussion on the mailing list about the Rust Iceberg repo and whether or not it made sense to integrate that into the main repo there. On the Avro side, pretty much almost every implementation except for the Rust one is all in one repo. And the only real big difficulty we've found there, aside from complexity of release scripts and complexity of CI, is that at least on the Avro side, we try to keep them all on the same version numbers, which has caused interesting aspects of trying to deal with semantic release and semantic versioning. But it looks like you guys are already doing separate version numbers for the Java and the PyIceberg, so that wouldn't really be where this would go on this side anyways with the Go one. It would have its own separate versioning anyways.
Yeah, so I feel very strongly about the versioning thing. I worked on Avro for a long time, and it's a nightmare trying to keep all the versions in sync in Avro, and like releasing another Avro version, having to release PHP that hasn't been updated in a decade. Under the same version number for some reason as Java. So I think we definitely want separate version numbers.
So you guys were already doing that with Python, so I didn't think that would be a problem.
So the nice thing here, I think the nice thing about one repo is all the issues go in the same place, right?
Yep.
So you get more eyes on the issue list. It's easier to go look at the Java code as well. Like you've probably already got it checked out. CI is a bit harder because you have, you've really got to keep things well partitioned and make sure that like only changes in this directory kick off the CI for that project. But you're probably pretty familiar with doing that. So
yeah, really the release scripts are where it's going to be the most complexity there.
Yeah. Well, the release scripts, at least in Python, we just have the release script entirely within the Python directory. And I think we may also, we use for release scripts Git archive that allows you to pass a number of paths that should be included. So at least
that should be easy to do with Go one too. But like I said, a release for the Go side is really just a Git tag. Is all you really need to do a release for Go versioning, because that's what gets picked up by the Go's module setup. It's just Git tags, and the way you do it is that the tag is basically going to be the path from the root of the repo to where the go.mod file is, followed by /v whatever version number it is. That's you do that Git tag, and that's release.
Okay, Franco, do you want to add?
I was just curious, would it also check out like the Java code and the Python code, because that might also pull in a lot of garbage? Yeah?
The way that Go stuff, I mean, since it's a Git tag, but the way that the Go stuff works is because you do the path from the root to the directory where the go.mod file is, and what Go's module does is going to use that to find the go.mod file, and then it's only going to package up when someone goes to download the package. It only packages up starting at that directory and then down.
Got it.
And then what happens is the various Go module proxy server things, some DB and all stuff. Well, essentially they'll check out the whole repo, because you can't really just check out a subdirectory of a Git repo. But then it will only package up that one directory, and then that's what gets cached as the proxy in the proxies. So that, if the user is not using the proxy, even the default one, then yeah, it's going to clone the entire repo and then just delete everything that's not the Go module part. But if they're using even the default, Go proxy for modules, which I don't know why anyone wouldn't at least do that as a default, then it's just going to download essentially a zip of the go.mod packaged files and any other stuff.
Great.
Is it a good idea to use iceberg.apache.org as the package name for our Go SDK?
At the moment, I have tentatively named it Ice Gopher, because Go's mascot is a gopher, is the really cute Go Gopher, and there's lots of puns and stuff based on that. So I have tentatively named it Ice Gopher, but obviously I am perfectly fine renaming it to just be Iceberg as the root module if that's what people prefer, or whatever people like, so on and so forth. I put a link to my current version of the code because when I mentioned it on the Slack, Baco asked to be able to see the code, so I tossed it up there.
Awesome. Well, great to have that. Sorry, go ahead. Who did I interrupt?
No, I was just finishing my nice little bit of code there, so you're fine.
Yeah. Okay. So that sounds good. It sounds like we're basically circling around. Keep it in the main repository. I think that's a good way to start off until people have stronger opinions. That sort of thing. So the next question I think is, how do we move the code into the foundation? So I think there's like the licensing and practical issue, which is like
I've already marked everything as Apache license 2.0, and already put the license on the top of every file in there.
Okay.
I'm used to doing that for the Avro one anyways. So as far as licensing goes, it's all.
Wow, yeah, the headers are all correct. So that makes things very easy. And I don't think that if we were to sort of slice this up into manageable size PRs, that we'd really need like a software grant agreement or anything like that. If you feel more comfortable with that, I think we could definitely accept one. But sort of up to you if you're interested in that. I do think that probably the best way to get the code in and like get more eyes on it and build some understanding is to probably have small PRs that a group of people review, just so that we can do two things. First of all, like having more people look at it raises awareness of like how Go is put together in like the PMC and committer base that's going to be pulling these in. And then hopefully what we can also do is use that as a chance to check, against the Iceberg spec or the other implementations, is this doing what we think it's doing, essentially, or are there any, misunderstandings within that code? So, I think that that's probably a good way to go. And Jacob, I saw that you said you would love to, assist with this. I think having another set of eyes that understand Go on it would really be helpful as well.
Sounds good. Yeah, I'd love to look at it and start using it myself for my little thing that I'm working on. Awesome.
Yeah. So how about just starting a few PRs, starting some very basic things and moving stuff in.
Yeah, sure. And I guess the way to do it to start off would just be, you want me to make a top, like right now the Python module has a top level Python directory and then has PyIceberg under it. You want me to follow that pattern basically?
I think that makes sense. Just create a Go directory within the repository and we'll put it all under that.
Cool. And then I guess, do people prefer me leaving the Ice Gopher name, or should I rename it as just as Iceberg itself? Like, what do people think there? Since Python is PyIceberg, so
I got a whole bucket of paint for this bike shed.
Yeah.
But my preference is just Iceberg.
That's my preference too, if we can get it. The reason why we didn't do that in Python is that someone taken the name. There was a lot of bike shedding there because we had to figure out, should it be Py-Iceberg or Iceberg Python, or Should we have the module name match the package name and stuff like that? So hopefully this is a whole lot easier. If Iceberg is available, I think most people would
all Go modules are identified by a full Git path for imports. So the name is always available because the import path is the whole github.com/apache/iceberg/ blah, 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 blah.
Fantastic.
So I'll do a rename in the package files and rename it all to Iceberg instead of Icegopher. And yeah, I'll throw up a couple starting PRs to get things going.
Awesome. Well, thank you. Really great to have more people interested and writing implementations and so on. So thanks a lot for your donation and work here.
Yeah, no problem. When I was at ApacheCon last year, and one of the biggest things I heard was people wanting non-JVM Iceberg libraries. So
good to know. Yeah, I'd also love to see a Rust one. Rusty, do you want to go?
I would say I think non-JVM Iceberg is really, really getting hot. And the other thing I wanted to share, because I didn't see it was on the agenda, and I'm sorry about this, but there has been a movement in DuckDB for a C++ based implementation of Iceberg scanning, which I think, Fako, you got some good feedback on some of those issues as well.
Go ahead.
I know that one thing that's being worked on by a couple people at Vulture on Data, where I work at, is essentially taking the scanning idea from Iceberg and generating a substrate plan that doesn't actually reference Iceberg from the scan, and then being able to pass that substrate plan to things like DuckDB or Velox or whatever, which then be able to perform scans or fetches from Iceberg tables without ever having to actually implement Iceberg inside of them, because you just need a layer in front that can generate a substrate plan from the Iceberg metadata.
So this is where things get really, really ugly. And
I was just going to say this is a lot, you know what I mean? Because I did some experience with Acero and actually proved out that this is possible, and I was really, really excited by it.
The substrate plan?
No, I didn't go with substrate. That's a layer on top of Acero inside Arrow. So Acero is the C++ streaming query engine of Arrow.
Okay. So, I mean, I think that the big question for non-JVM is like, where is the best place to concentrate effort and put work? I like the idea of, interop between DuckDB and Arrow and anything using Arrow, including, polars and Acero. I think that, we still want it to be very usable for people. And so like I get worried if we're talking about like just passing a query over to DuckDB, because I don't want to just use DuckDB as an engine. I want people to be able to like write a query in DuckDB and have that query, actually, I mean, maybe we just pass that off to Arrow and say, hey, go plan this, right? This has Iceberg, go plan this scan. And like, plug into the DuckDB planner that way. That's definitely a possibility, but I would really love to make sure that it feels native, right? I think that the problem that we have currently with the PyIceberg support for DuckDB is that you've got to manually pull out those filters and say, okay, take this table, filter it by this, and then plug that into DuckDB. Then take this table, filter it by this, and plug that into DuckDB. So although we have, this, integration with REST catalogs and Python and DuckDB, the usability is still pretty bad in general. And I think that we want people to, really just be able to write SQL or write polars or whatever and have that baked down to, what they want. I'm a little skeptical that the substrate approach is going to give us that, but I would be happy to be wrong here, and we're open to, I think, any implementation that that actually gives us that broad support.
A point I would add, as someone who's trying to really push this, is that the statistics of the tables is actually really important to the query planning, and just having a function to scan a table is insufficient to do a really efficient query plan when you're doing joins. So I think there may have to be additional functions that kind of bring out the Iceberg statistics up to the query engines so they can get a better estimate of, say, like the number of distinct values that the scan can potentially produce.
Yeah, and we're still producing, or we're still working on those things for the other engines. Trino has recently added support for NDBs on Iceberg tables. We're working with Redshift for the same sort of thing. We do want to get those in, but even before that, right? If we look at this as, you give me filters in a table and I give you arrow buffers, then you don't get any of that, right?
I agree.
You're already sort of hosed, and so what we do on the Java side is the core library just does the planning, right? You say, here are my filters, here's everything. Give me the set of tasks without actually reading them, and then from that set of tasks, you usually aggregate and go over and say, oh, okay, well, I know I've got this many files, they're this size total, and given this projection, I can estimate the total size of memory. And so like we at least have some sort of statistics about the shape of the data. And we're always looking, by the way, to improve on those things, right? Like, how do we get better metadata faster for job planning? Because not everyone wants to get all of the tasks and do all the metadata planning before knowing the shape of that query.
I agree. I think it's a very interesting situation we're in. Like, I can see where we want to get to, but I know there's a lot of steps. Kind of, we're going to be wandering a little bit in the community finding its way. Like the current proposal of Arrow's dataset protocols didn't quite nail this yet either. So I think I would say like we're just a couple months away from getting something clear, aligned across all the engines. And then even if we do decide on a Acero or Substrate, there's not clarity on which execution engine of Arrow are we talking about. Is it Arrow C++? Is it Arrow and Rust? Like, there's many Arrow flavors, even if there's one Arrow spec.
Well, is there even the idea of a task in Arrow that you can open?
Yeah, there's.
Because that's what we produce. Is like, here's a task.
Acero's way of computing stuff uses a tree of nodes, and the nodes themselves are would be the equivalent of the tasks.
Oh, okay. Yeah.
And the tasks are things like scan, filter, hash, those types of things.
Yeah. The other thing there is those nodes need to implement Iceberg actual scanning, right? So one of the areas that we have trouble with right now is even after we plan something, right? We can say, here's a file that you need to read, and here's the schema that we expect from that file. Well, we use ID-based column resolution, which is not supported in Arrow. So then we've got to we basically read the Arrow buffers, and then we reorder them and put them together in a different schema in Python, and then sort of pass that all back down to Arrow and say like, hey, this is a data set now. So it gets real.
So there's a couple things going on there. Is one, there is the attempt at trying to standardize a data set protocol type thing that's happening with PyArrow and whatnot. The two, Arrow's data set in Python is really just a small veneer on top of the C++ data set anyways. And all you really have to do is create a Iceberg format for the data set. And then as long as that can handle the interface, which can involve predicate push down and things like that, then it would just plug in with the rest of the Arrow data set stuff.
All right, I think that we should probably have more detail on like what we need to produce, because I'd love to start working on the C++ implementations of these things. so that we can like actually do that push down, right? Like maybe Java does the job planning because that's what we currently have, but then we can push that down to Arrow and like reuse that code so that when Go says, hey, go read this or give me Arrow, you know, an Arrow representation of this task, whatever that is, we get the same thing across both without having to like jump up to Python from inside a Go library in order to.
I think you hit the nail on the head. Like, I'd really love just a C-level implementation of Iceberg that produces an Arrow buffer, a stream of Arrow buffers. Do you know what I mean? If we can deliver that, all these other languages can become a lot simpler.
That's my intent with the Go library, is that it's going to produce a stream of Arrow records from a query, from pulling from an Iceberg table. That's my intent that I'm building out towards with the Go library.
But I mean, but even there, right? We're saying that Arrow lacks a common representation for a task. And
well,
Iceberg
the for a task would be substrate.
Is it? I mean, can you express a task as in read this file and apply these deletes?
Yes.
Yes.
It's called an anti-join.
Yeah,
you can put it into an Acero as a couple of nodes, and that's what got me really excited about it, because I was like, I can put this together in an afternoon.
Yeah, and that's why there was looking at like trying to represent a Iceberg scan that's including the push down, including the deletes and everything, as a substrate plan.
All right. I mean, that does make a
collection of tasks.
So we're saying, like, basically we're going to hand off a lot of the representation to substrate at that point.
And the other benefit you get is that if you can represent the plan as a substrate plan, then any engine that understands substrate, whether it's DuckDB, Delox, Acero, whatever, can then use that substrate plan to perform the operation, regardless of who planned it. Whether you planned it using a Python library, whether you planned it using Java, Go, whatever, if you have a substrate plan, you can pass it off to any compute engine that can then the substrate, and then it can do the stuff.
Yeah, I'd almost rather have the planning in Arrow than just saying like, hey, we'll use substrate as a way to pass around the plans. I mean, it seems very. It seems like that's doing a lot of work, you know, building this compatibility layer, no doubt, but then getting to the point where like DuckDB still has to do its own planning.
No, I agree completely that getting it inside of those is going to be much more convenient. Absolutely.
Yeah.
You know, the drawback there is, you know, making sure that you have to make sure it's like Rusty was saying, it would have to be like a small C library to make sure it's easily pluggable everywhere. Because you don't want to have to, because if you're writing it in something like Python, you don't want other libraries to have to call out to that to get the plan.
All right.
They're just build it themselves at that point.
I can think that like substrate as a representation for tasks is a reasonable thing. We still have to make sure the projection is correct, right? Because you're going to have some node that is like, read this file with this schema, and you need to know that projection is occurring correctly there. But that does allow us a lot of flexibility for things like residuals that we calculate. You know, so hey, if there's no residual, then don't slap a filter on top of that task, and things like that. So I could be definitely convinced of that direction.
I think what would be super useful is if we could organize some communication between all these people trying to implement these particular bridges. It could probably save a lot of effort, because looking at the DuckDB implementation of Iceberg so far, they're not digging into substrate or Acero. They're doing the anti-join using the existing DuckDB engine.
Yeah. Well, I somewhat expect DuckDB to do their own thing on the implementation side. I mean, really, because there's not a library that they could use for planning, and even if there were, like they tend to like write their own from scratch for performance reasons, which like good for them. So I'm not expecting a ton of like code sharing across, although like if Arrow again supported like correct column projection, we'd probably be like, you know, that would be a really great step towards compatibility.
If Arrow is not supporting quote unquote correct column projection, can you point me to an issue on the repo there so I can address that?
Faco, do we have an open issue for column projection? I think what we did was we just wrote it in Python.
Yeah. So if a column is missing, we just create like an empty buffer in Python.
But Faco, maybe we can open an issue and coordinate on that issue on the Arrow side, because I think it does require or it would make the most sense to have like a C++ implementation of like Iceberg column resolution.
I agree. Yeah. I can open an issue.
That's easy. So send me the link to it.
And then we also need, could you also send a link to the row ID or row position issue? I'm not sure where we're at on that one, but that's necessary for applying deletes.
I mailed the mailing list about that probably about 2 months ago, and I think they said that's a good idea, but I don't think it really went anywhere.
Yeah. So we'll need to have that. I think getting some of these primitives in the Arrow level is going to really make this go a lot faster.
Well, happy to help there.
Thanks. We really appreciate it. It's great to have you guys joining us. All right. Anything else, or should we adjourn? I think we're already like 6 minutes late. So. All right, thanks for coming, everyone. Great to meet you guys, and thanks for your recent contributions. Really great to have you in the community.